Welcome to live lecture 3 for NTI week 3. Again, if you're here, please throw something in the chat. I have given feedback on all of the create task ideas that were turned in. If I have not, or if you have not seen feedback from me, then you should reach out to me. And we've got 7 explore tasks that are still out. So if you're watching this and you're an explore task procrastinator, get that done before I come and knock on your door. Just kidding, maybe. All right, so let's get started. For this week, it's pretty much the same stuff as last week because I'm just going to continue to remind you that as you start your create task development, you really need to be keeping notes on when you engage in the iterative process. You should continue to reflect on the samples from the create task as you do your work. And then for this week, for this week, there is no deliverable, meaning I don't have anything that I want you to have turned in by Friday. I want you to ask questions as you have them, okay? I've only gotten maybe 3 or 4 questions, which is indicative of maybe we're not really starting to move forward with the work, and that's okay. You know, we just really thought about ideas this week. For the next, 4 weeks, you should be focused on writing this thing, getting this thing together, and really you've only got about 3 weeks to do the coding, because in that last week or so, we're going to really focus on building your video, making sure your written responses for your video are good, and how to do all that. Okay, so again, after today's lecture, we're going to have a brief Google meeting, and there's the link right there. It's also in Google Classroom under the announcement that I posted yesterday. I added a link in there, so if you want to go back and check Google Classroom or Slack, it's there. I'll give you a minute to take that down if you need to. Amir, good morning. It's good to have you here, sir. All right, so let's go ahead and get right into it. The first thing we're going to do is we're going to go over a sample. This one's going to be a little faster. I won't dwell as much on some of the stuff I've already talked about. We're going to look closely at the like row 4, 5, and 6. And where they talk about the iterative process, where they talk about their parent and 2-child algorithms. And then we're going to look at how we would go about starting our project. And I've talked with you about this before, but we're going to look at a finished project, and then I'm going to talk to you about like how I would start that project to prevent myself from getting bogged down too much, to kind of organize my thoughts. We've seen this before, but I'll show it to you again because since you guys are working on really your own ideas, these are completely novel ideas. I've given you no prompts whatsoever. It's really important that you start to structure your thinking and organize your thoughts, because it's going to help you write your code better, faster, and you'll be able to keep track of that iterative process more accurately and comprehensively. Okay, so let's get right into it. First thing we're going to look at is our Codeorg sample. I think I've already got it up. So what we're going to be looking at today is the highest scoring sample. That's sample C, and we're actually going to look at the written responses. Let's see, it's not this one. It's okay. Let me get my tabs organized here. So we're going to be looking at the written responses and the sample itself. We're not going to watch the video simply because I don't really see that as a good use of your time. I'm trying to keep this as brief as possible for you all. I know you want to go back to doing your work or just relaxing this morning, whatever it is that you need to do. Okay, so let's go ahead and throw up this sample. As you can see, this student scored a 7 out of 8, which is really solid, right? They did not score row 6, and again, this is that elusive parent-child algorithm that we have not seen a successful implementation of yet. Okay, we already talked a lot about row 1. They're making a video. They're talking about the purpose of the program. They're putting that in their narrative for response 2A. we'll skip right past that, okay? All right, so let's focus on 2B, which is where we talk about the incremental and iterative development process of the program. And I realize that I need to zoom this in. Okay. All right. If you guys have questions as I go through this, go ahead and throw them up in the chat. All right. So for this row, the response earned a point. And the reason they earned a point was what they've highlighted here. So the response states, I wrote this program first by creating an identity for the user, and then by creating worlds with minigames within them for the user's chosen character to complete. So this describes how they used an iterative process solely because they essentially said, first I did this, then I did this, and then I had an issue and I resolved it. Okay? That does not fully cover row 2's and row 3, but it meets the requirement for row 2. Describe or outline steps used in the incremental and iterative development process to create the entire program. So just by using the language of first I did this, then I did this, then I resolved an issue, they basically met the requirements for row 2. That's really simple, right? Now Code.org does go on to say that even though this response received the point in 2017, we're not fully convinced it would receive the point in 2019. So just like Dota 2, there's lots of power creep in AP responses. So as students get better and better at responding to stuff, AP reader expectations get biased to look for better and better responses. Now you might not agree with that, but that's the harsh reality. So we live in that reality and we adapt to it and overcome. Okay. So let's talk about where they identify at least 2 program development difficulties or opportunities, and then describe how they resolved or incorporated the difficulties or opportunities respectively. And again, this is row 3. So they state that the response describes 2 difficulties that were encountered and how these were resolved. The first difficulty is carrying of inputs to a different screen. It's resolved using a global variable instead of a local variable. The second difficulty is moving of the user's character between screens, resolved by using a variable and an if statement to set the image of the user's character throughout the program. Now, if you recall, last week we looked at a really similar response, and they basically stated that they had a problem and they said that they resolved it. Okay? And this kind of looks the same. But if we go and look at the actual response, we see a little bit of context here that kind of helps us, right? They say, my first problem arose when I tried to do this, and then they describe why that had happened, and then they describe the resolution. Now, what I would say is the reader, or Code.org, has only highlighted the problem and the resolution. So you might think, well, that's pretty much the same thing as last week. And I would be inclined to kind of agree with you, right? But remember, readers are human beings. So we're giving them some context here and saying, like, why did this problem happen? Well, it happened because I'd initially used a local variable. The user input was only recorded to the screen on which that local variable was provided, right? Instead of the entire program. And they actually address that down here in why they gave them a point. So maybe it's just they didn't highlight effectively or whatever it is, but you need to talk about the problem or opportunity. You need to talk about kind of why it exists, and then discuss that resolution, okay? Try to be comprehensive, clear, and concise as possible, right? Leave nothing up to inference. All right, so that's row 3. Now we're going to look at row 4, which is the code segment that implements an algorithm that is fundamental to the program to achieve its intended purpose. Remember, again, we discussed last week that you don't want this algorithm for row 4, 5, and 6. You don't want that algorithm to be shoehorned. Like, you don't want it to come out of nowhere. It should fit with the natural program, or let me think of the best way to say this. It should naturally fit with the rest of the program, right? If you're writing a journaling program and then you've got like a calculator algorithm in there for some reason, that doesn't really make sense. I don't know how you would justify that being in your journal code. Maybe you can, but I wouldn't risk it. Okay, so we actually need to adventure over to their written responses so we can see where they've or what they've selected as their algorithm. So we're going to go over there, and you can find this by clicking on this link right here. So this is the Create Written Responses Sample C 2017. So we can go over here, and this is their actual full response. Okay. So I'll scroll up to where I need to be. Okay. I'll zoom in as well. All right. Now, they've chosen 3 algorithms here that are theoretically tied together, right? We can see just by kind of skimming that there's some math here. We've got selection, an if statement. Got if statements here. This is maybe math. I don't know if we'd really count this as math or not. Basically, there's 2 games going on here in this fish game, and again, guys, this might seem like when you look at all this, you're like, oh, that's a lot of code, right? And you don't have any context because you don't know how this program works. Honestly, the readers aren't necessarily going to understand how your code works either, right? Keep in mind that some of the readers are very inexperienced programmers in the first place. So you want it to be abundantly clear when you select an algorithm. You need to be abundantly clear in your written response what it's doing, okay? Because they might not understand what like a simulation. Well, they should understand what a simulation is. That's a lie. But they might not really understand the mechanics of how your simulation works until you are describing it to them in the written response. So you want to be really clear. So again, if you're overwhelmed by this, it's okay. Just know that you need to respond in a way that the readers understand your code effectively. Okay, so let's read their response here and see if we can understand. In the underwater adventures, there's a mini game in which the user must collect 20 coins to win. Once that's complete, the user plays a second mini game where they collect a scale, and then when both are won, that level is complete. Okay, so they say that the code executes the concept, incorporating a variety of variables and functions to create an algorithm that calculates when the treasure game and scale games have been won. So that's the overall purpose, right? And then, okay, they say the first set of code shown above, 1A, is the function that runs the treasure game. Each time the coin is clicked, the variable treasure score increases by 1. Once the score reaches 20, another variable got coins increases by 1, and the screen switches to a win screen. Okay, so if we go up and look at 1A, we can see that they're increasing their treasure score when they get a coin, or when we click on a coin. All right, that sets the position of the coin to a new place on the screen. It changes the text to say that they've got a new number of coins collected. And then once that reaches 20, it's going to set got coins to equal 1. Now, why you wouldn't set got coins equal to true, I don't know, but we'll just we'll leave that to the imagination. All right. So once that happens, it says, let's go back. It says it switches to a win screen with a continue button, and then the scale game works pretty similarly. If the user clicks the continue button after winning either game, the second piece of code is shown, that's 2, and that uses an algorithm to check if both games have been won. So we've got one game happening right here, and then we've got another game happening right here, and then this one checks for both games being completed, I guess. Okay, and so we've got some logical elements here. We've got logical elements here. Not a lot of math going on. I mean, there's some, right? But again, you'll see that this algorithm scores most of the points except for row 6. All right. So there we go. And if we go back to the sample, we can read that Codeorg states the selected algorithms use logical concepts, and so the logical concepts that it uses are sequencing and selection. There's no looping there, right? It tells us what the response states, what the purpose is. It meets the requirements where The selected code segment implements an algorithm. That's doubtless, right? It definitely implements an algorithm. The selected code segment implements an algorithm that uses mathematical or logical concepts. Yes. And it explains how it functions. Yes. And it describes what the selected algorithm does in relation to the overall purpose of the program. So basically, if you are writing code and you write something that makes sense for row 4 and row 5, you're probably going to meet these requirements, okay? It should be tough for you to not have math or logic. Notice it's math or logic. It doesn't have to be both, okay? It shouldn't be hard to meet these two. But when we run into an issue, is this row 6, right? And it's that the selected code segment implements an algorithm that includes at least 2 or more algorithms. At least one of the included algorithms uses mathematical or logical concepts, and we explain how one of the included algorithms functions independently. Okay, so you've got to have that parent algorithm that calls 2 other algorithms, right? Those 2 algorithms need to have, or at least one of those 2 algorithms needs to have some math or some logic, and they need to be related to the purpose of the program, and you've got to explain how they work, right? To receive the point, right, here, so they don't earn a point here. It says, while 3 algorithms are shown, there is not an algorithm that is using at least 2 or more. The 2 algorithms independently call the third. Okay, so there's 3 algorithms there. 2 of those algorithms call the third algorithm, but there isn't a situation that's like this, right? Let me put it in Paint real quick. I did not practice this, so prepare yourselves for nonsense. Let's see. Big brush. All right, cool. So if we have algorithm A and algorithm B here, and we've got another algorithm C, if A calls C and B calls C, that's not going to get you a point. Okay? If you have 3 algorithms A, B, C, it doesn't really matter how complex they are, right? If you have this, I need to change my size. Are you kidding me? Paint. Ugh. Ignore these arrows. Goodbye. Goodbye, arrows. Okay, if you have algorithms A, B, and C, okay, and they're all super complex, they do cool stuff, they could literally solve world hunger. AP's not going to give you a point for that, okay, because these are 3 independent algorithms. What you have to have is like this. Oh my gosh. Don't save. There we go. Problem solved. All right, what you have to have is A, algorithm A, that calls B, and then has C as well, like that, okay? That's how we score the point. That's how we score the point. Doesn't matter. At least one of these has to have math or logic. Could be this one, could be this one. All right? They don't have to be super complex. They just have to contain the elements required by AP. Okay? So make sure, as you're thinking about your idea, be thinking about where this is going to belong. And it can be something also that you sort of discover along the way, okay? The easiest way is to think about, like, you know, what is my most complex algorithm going to be, and I can work backwards from there. But you can also just discover it along the way. I would encourage you, though, to ensure you're going to get the point, to really start thinking ahead and knowing what that complex algorithm is going to be, okay? All right. Remember that for row 7 and row 8, all we're really doing here is we are selecting a student-developed abstraction, not something that already exists inside the code, right? We can't say the print statement is our abstraction. We can't say that the length function of Python is our abstraction. Now, if you write an abstraction of your own and use the length function, or you use a print statement, that's okay. It's just that the abstraction you identify has to be one that you created, and it can call as many built-in stuff, or as much built-in stuff as you want, okay? So that selected code segment is a student-developed abstraction. That's row 7. Remember, this is a different code segment. It can be the same one, but maybe choose a different one, especially if you're working collaboratively with someone else, okay? You can't choose the same one. And then we want to explain how the selected abstraction manages complexity. going back to doing a good job of keeping notes on what you've done and doing that iterative process, and also doing what I'm about to show you with organizing your code, right? That makes it a lot easier for you to answer this one right here. If you just wrote some code and the abstraction exists just because you put it there, like if that's what's in your head, you're going to have a hard time answering this accurately and in a way that's probably going to score a point, okay? And we can look at this briefly. Basically, this student, they made a big function that has set up blast off. I don't know what this has to do with the other game they made. Presumably you're a fish that goes to Mars. I have no idea, okay? But there you go. They've got, this is a really, really straightforward, just a bunch of text hiding, moving some stuff around. This is all very Code.org stuff, which is okay. If you're interested in doing that, go for it. But it's pretty simple, okay? This is the same as a bunch of print statements. It's just changing the display of the code. All right? So the next thing I'm going to do, now that we're done looking at that sample, is I want to show you all, like, if I were starting from an idea from scratch, how would I organize my thoughts in the beginning? And I've showed you this before. So while I'm bringing up PyCharm here, which shouldn't take me more than a couple minutes, go ahead and if you got any questions, just throw them in the chat, and I'm going to get myself organized for PyCharm, okay? Actually, you know what? Let's drop this. Yeah. Okay. We'll start from the blank portion. Okay. Let me check the chat. See if I got any questions. Omar, your program does not need to have visual. It has to have something that you can record to demonstrate that your code is running. So that can be the Python console. You don't have to have a visually, like, you don't have to have colors, shapes, all that kind of stuff. You just need some way of showing the reader that your code is actually running and doing something. For Python, if you just want to represent that in the console, that's perfectly fine. It's a good question. And keep in mind, guys, that this task, AP-CSP, is really oriented towards beginner programmers. And so a lot of the samples that you're seeing, they're coming from students that have never programmed before, and they're using that Code.org tool to start programming. They're learning programming in that way. And so, yeah, don't feel like just because you're seeing all these samples that have visual elements, don't feel obligated to have big fancy visual stuff of your own. That's not necessary. That won't influence your score. Good question. All right. Well, we'll go ahead and kick this off, okay? So let me show you the finished product of this quick project first. So I got this project from, well, okay, never mind. I got this project from a great course called 10 Apps to Jumpstart Python, and it comes from a guy named Mike Kennedy. If you're interested, actually, you know what? I meant to share this link with you. I'll put it on Google Classroom. I've shared it before, but if you go to Talk Python, if you like podcasts, first of all, this guy's podcast is really good, and he has a training site, and there are lots of good courses on here. and you can get a discount as a student. Or if you're interested in 100 days of code in Python, I can send you this, and the cost is like $10 or $15 or something. Okay, so I've got a discount code from Mike Kennedy where we set this up so that you guys could have access to this course right here for $15. So if you're bored and you want to learn a lot of awesome stuff, if you want to be smarter than me, when we get back to our senior year, because you're pretty much a senior right now, then you should check out this stuff, and I can help you at least get a discount on this one. Or if you got a birthday coming up or something, you want to check one of these out, you can. But our thing we're going to build today comes from this one. It's called Python Jumpstart by Building 10 Apps, and it's a lolcat factory. I don't know why I opened that. If you don't know what a lolcat is, you're about to find out. All right, so let's go ahead and go back to PyCharm. I picked this because it was fun and simple, and I thought you guys would enjoy it. So if we just run the finished program, here's what's going to happen. We are contacting an external server with our Python code to download some cats, apparently. And then it opens up a folder on our computer and shows us that we have gone out and downloaded, let's see, 8 random cat pictures. And I can share those with you now. This cat says Icon has programming language. This cat is in our quantum box. Maybe. Schrodinger's cat there. I is 10 ninjas. There has been a failure on the internets. Do not worry. We as professionals. And then we've got some repeats here. I don't know what that's all about. But anyway, those are lolcats. So, that's the finished program. But let's sort of put ourselves in the mindset where we are just getting started with our lolcat code, right? We have no idea how exactly all of this is going to work. We just know that we want to write some code that goes out to the internet, gets random lolcat images, and saves them to our computer so we can share them with other people or whatever, right? So the way I want to start this is I want to think about the actions that the program is going to take. Now, for those of you that are working on programs where you've got complex data, and well, not necessarily complex. What I mean by that is, you might have something where you want to represent like a character. I know that some of you were thinking about building like a RPG character builder type thing, right? So another way to start this process is to think about what's the data that my program is going to need, and sort of start from there. And you'd have like class, character, etc. Right? But another really good way to start this process is to think about what does my code need to do, and think about that in terms of plain English, right? So before I worry about any import statements, any sort of complex stuff, I just want to describe what do I think my code is going to need to do, okay? So the first thing that I want to do, right, is get cat from internet. So I'm going to have a function called get cat from internet, right? And then I can say pass. Let's see. I want to be able to save those images, right? So I'll have a function called save image. And I probably want to put that image in a folder somewhere, so we can assume that this save image function is going to need a folder parameter. We're probably going to want to name that image, so we'll have a name, right? And then whatever image I'm saving, right, that's going to be some form of data. And so I'll need that as well, and then I can say pass here. All right? And then, let's see. I always have like a header. We've done this before, so we always have a header here. That doesn't have anything. Might be the first thing I write. What about, let's see, if I'm able to save the image, what if I don't have the folder, right? What if I don't have the folder where I'm going to save the image yet? And I also need, something's got to fill out this parameter here for save image. Something's got to fill out the folder parameter. So I probably need to get the folder, right? So I could say def get or create output folder. Okay. And that, we'll assume that doesn't need anything, right? I can't really think of what that would need, and I can say pass there. All right. I've already got my get cat from internet, or get cats from internet is a better name. The last thing that code did, you know, I showed the folder. I showed the folder where the cats were stored, so I might want to have that as well. I might say display cats. Okay. In order to display the cats, we can assume that we'll need the folder that the cats are in, so we might give it a parameter of folder. And let's see. We've got our get cat. And then we also need to go out, well, we need to go out to the internet. We're getting cats from the internet. We'll just leave this like this. This might end up calling more functions, so this could be an example of where we might run into that complexity. But in addition to this, we know that once we have all these subordinate functions, we're also going to have a main, right? So our main is going to contain the calls to all of these other functions. So if you think about this, right, this can be a parent algorithm that calls child algorithms, and as long as what's in your main meets the complexity requirements, and as long as you explain it well, you could hit that row 6 right here. Okay. That main function, really, that could be the core of your program from which you are able to achieve that complexity, but you got to be careful that you explain it well, because a main function has to contain on its own, I think if we go back we can see, so I'm going to switch gears here real quick. That main function, in order to get a score for row 4 and row 5, that function, the main function, has to have some mathematical or logical concept in it. But you're probably already thinking ahead like, oh, I've done that before, right? I've had a main function where I had an if statement, where I had some kind of menu maybe where I'm, you know, looping, I'm doing an infinite loop and I'm saying, hey user, what do you want to do? That could be part of that complexity, okay? So let me go back to this real quick. We'll just kind of finish our thought. So our main function, let's see, we're going to have a folder that comes from get or create output folder. We'll download our cats. So we'll get cats from the internet, and then we'll display cats using that folder. And we can presume again that save image, right? This might be nestled inside of get cats from internet. So I might come up here and say I'm actually going to call save image here. And then I would need folder name and data. But I'm not going to go through and actually write all this code. I'll show you the final code here in just a second. What I want you to understand is that if you're able to at least start organizing your thoughts in this way, it's going to be much easier for you to get a good handle on where you're going with your code. Okay, so I strongly encourage you to worry less at the beginning about how am I going to figure out how to get cats from the internet. Maybe just write down that you need to do that and let that develop organically. Okay. And you can use like a snowball method, sort of mentally. You can start with the easy stuff and work your way up to the hard stuff. Or you can use that like avalanche method, right? Where you start with the hardest thing, you're going to figure that out first, and everything else is so much easier. Either way, you're going to be doing lots of iteration, so you should make sure you're taking notes. This is going to be an incremental process where you're making mistakes, going back and fixing them, and that's what makes for a good coding process. So I'll show you the final code here. We're using some different modules and stuff. You can see we've got os.path in here where we're building paths or using paths from our computer to store things, create those file paths. We've got some iteration in here where we're downloading cats. It's using this cat service. So notice that I've got my code kind of separated into two different files. So when I say cat service.getCat, check this out. I can go to the declaration, which doesn't work. Hold on. Go to, whoops. Okay, never mind. It doesn't work. If I look at getCat, that's coming from cat service, right? That's using this URL. It's going out and getting that data, and it's saving that image using the save image function right here. Okay. So anyway, My point of this wasn't to show you this entire code, but I wanted to show you this technique of thinking about how I'm going to go about getting those cat pictures from the internet. Okay, that's all I've got for today's lecture. And now I'm going to go ahead and transition over to the Google Meet. So once again, here's the link for that. I'm going to end the stream here, and I will